Hello, this video is for the linear inequalities portion of your review packet for your semester 1 final. Remember, you can skip around and just watch the solutions for the problems that you struggled with or had questions about. We're going to start with the first one right away. 15 says determine if each point is a solution to the system of inequalities. So we're given two inequalities over here, and we need to check if each point is a solution to them. Remember, so if we're checking 3, 3, and a here, their x and y are both 3. We need to plug it into each inequality and see if it holds true. So, I'm going to do that. Let's plug it into the first one. Alright. So we have 3 times 3 plus 3, and we're checking, is that greater than or equal to 1? So I'm going to put a question mark. 3 times 3 is 9, plus 3 greater than or equal to 1. Well, that's 12. That is greater than or equal to 1. So it works for our first inequality. Check our next one. We have 2x minus 5y is less than 10. So we have 2 times 3 minus 5 times 3. And is that less than 10? We're checking that. So a question mark. So 6 minus 15 is less than 10. Well, that gives us a negative 9. That is less than 10. So both of them check out. So for this first one here, I would say yes, it is a solution. And I am going to erase my work, so I have more space to work. So I'm going to erase some of that. And then let's look at our next one here. Alright, so that's for the point 5, 0. So same thing. So if I'm going to plug 5, 0 into 3x plus y is greater than or equal to 1, well, that's going to give me 15 plus 0 is greater than or equal to 1. 15 is greater than or equal to 1, so that checks out. My second one is 2x minus 5y is less than 10, so 2 times x is 2 times 5, which is 10. 5 minus 0 is 0. Is that less than 10? So is 10 less than 10? No. That's false, so then this would have to be a no as well. Okay, erase some of this again. Bear with me so I have some room to work here. And we'll check our next one. So our next point is 1, negative 2. When I plug that into my top inequality, I get 3. And that's going to be minus 2 is greater than or equal to 1. So that gives me 1 is greater than or equal to 1. That's true. And then we're going to get 2 times 1, which is 2. And then we have negative 5 times negative 2 is plus 10. Is that less than 10? So is 12 less than 10? No. So this is also a no here. Let's keep going on to our next one. We're at 7, 1 in D. So we're going to get 21 plus 1 greater than or equal to 1. Well, that gives me 22 is greater than or equal to 1 is true. In the bottom, I'm going to get 14 minus 5 is less than 10. That gives me 9 is less than 10. Also checks out. So that is a yes. And then for my last one, I'm going to get negative 9 plus 10 is greater than or equal to 1. Which gives me 1 is greater than or equal to 1. That works. We're okay. Bottom one, I'm going to get negative 6 minus 50 is less than 10. So I'm going to be negative 56 is less than 10. That also checks out. So also a yes. Looking at the next one, number 16 says the boundary lines are graphed for each system, shade in the solution to the system. So the lines are graphed, we just have to put the shading in the correct area. So let's look at the first one, y is greater than or equal to 1. Well, that's got to be our line here. So that's right there. That is y is greater than or equal to 1 right there. And I know if I have to be greater than or equal to negative 1, those are the numbers that are above. So I'm going to draw some lines in here to help me see where I'm going. My second one is y is less than or equal to negative 3x plus 1, so that must be my line here. And it has to be less than that, so I'm looking for below. Below would be this area here. So my solution is the area where I have pink and blue. That would be my solution area. Looking at our second one, y is less than or equal to 1/3 x plus 1. That one is going to be our one with a less steep slope, so that must go with this line. 4x plus 1 is going to go with that line. So less than or equal to that, that's below. So let's draw some pink in, and then less than or equal to for the 4x plus 1, also below, which goes this way. So I'm looking for where they overlap, and that looks like that area there. So anything in the black now where I shaded in would be a solution, any point there. For the next one, it says graph and shade the solution to the following systems of linear inequalities. So y is less than or equal to negative 2x. So for that one, my y-intercept must be 0. So I'm going to do that one in pink. So it goes through 0, and then I have a slope of negative 2. So I'm going down to over 1. So I draw that in. It is just less than, so it's going to be a dotted line. So your guys will be a little straighter than mine on my iPad, but you get the idea. It's going to be dashed. Okay, and then my next one I'm going to draw in first before I shade. So 1/3 x plus 1, up 1 over 3, down 1 back 3, also dashed. Okay, let's go back to pink. So it has to be less than that. So then I am looking for the area under there. For my blue, y is greater than 1/3 x plus 1. That would be above. Looking for my pink and blue overlap. I'm drawing dotted black lines, and you'll notice since the original lines were also dotted, and that's my solution area. For my next one, x plus y is less than or equal to 10. Let's solve for y. So I get y. Let's fix that real quick. So I get y is less than or equal to 10 minus x. So 1, 2, 3, 4, 5, 6, kind of up here. Didn't make enough room on mine, that's okay. But I go down 1 over 1. So I'd be at like 1, 9, 2, 8, 3, 7, so on like that. And that's solid, so mine's not perfectly straight. Yours hopefully is a little bit better. For my other one, I need to solve for my y again, so I'm going to subtract 2x, so that leaves me with negative y is less than or equal to 9 minus 2x, divided by negative 1, right on the bottom here, so I get y is now greater than or equal to, because I had to divide by a negative, negative 9, that's going to be plus 2x. So again, I'm somewhere down here, so my y-intercept's at negative 9 off my graph. Then I'd be at 1, negative 7, and so on. Also solid. So let's go back to pink. Less than or equal to 10 minus x. So that's a lot. That's everything under here for pink. And then blue is y is greater than or equal to the negative 9 plus 2x. So that's everything above here. So it looks like where they overlap, and now I have solid lines. There's the boundaries, and it's everything in here. Okay, for the last one, it says Charlene makes $10 per hour babysitting and $5 per hour gardening. She wants to make at least $80 a week, but can work no more than 12 hours a week. Write a system of linear inequalities to describe the situation. So let's pick our variables. So we have an x and we have a y. Let's make x babysitting. And if you did this the other way, you'd still get the right answer. Y is gardening. And let's see, we have two limits here. She wants to make at least $80. That's the first thing, but can't work more than 12 hours. So let's look at just the money she makes. So for the first part, she makes $10 an hour babysitting and $5 per hour gardening. So the way I show that is $10 per hour babysitting. So 10x, $10 for every hour babysitting, plus the money gardening, which is $5 per hour gardening. She wants to make at least $80 a week. So she's happy if she makes 80, but she's also happy if she makes more than that, so greater than or equal to 80. And for our second one, she can't work any more than 12 hours. Now, I don't have to use the 10 and the 5 that I used here, because that's talking about money. So when I talk about hours, I just need the hours worked, gardening and babysitting, and that has to be less than or equal to 12. If you had to graph these, which this doesn't ask for, you'd want to solve them for y first, and then go ahead and graph from there. Thanks for watching!